Have you ever noticed something strange about where we launch rockets? Cape Canaveral, Kourou, Tanegashima, Sriharikota, all of them sit remarkably close to the equator. Is that just a coincidence, or is there a deep physics reason hiding in plain sight? Here's the key. The Earth is spinning, and if you're standing on the surface, you're already moving fast. At the equator, you're whipping around at about 465 meters per second just by standing still. But at higher latitudes, you're closer to the axis, so you move slower, and at the poles, you barely move at all. Let's make this precise. The surface speed at any latitude phi is omega times r times cosine of phi. Omega is Earth's angular velocity. R is the radius. At the equator, cosine of 0 is 1. You get the full speed. As phi increases toward the pole, cosine shrinks, and so does your free velocity. Let's plug in real numbers. At the equator, 465 meters per second. Cape Canaveral at 28 degrees, about 410, at 45 degrees, only 329, and at the poles, 0. That's a huge range. Now here's the question. Does this speed difference actually matter for getting to orbit? To orbit Earth, you need roughly 7,800 meters per second. That's enormous. But launching from the equator, you already have 465 of those for free. That's 6% of the total. Sounds small, right? But in rocketry, 6% is anything but small. This is the Tsiolkovsky rocket equation. Delta V equals the exhaust velocity times the natural log of the mass ratio. Notice that logarithm. To get more delta V, you don't just add more fuel linearly, you need exponentially more. So saving even 465 meters per second means you need dramatically less fuel. That's the rocket equation's gift to the equator. And there it is. The Earth's spin at the equator hands you 465 meters per second for free. Thanks to the exponential nature of the rocket equation, that translates to roughly 10 to 15% less fuel needed for the entire mission. That's tens of thousands of kilograms of propellant saved just by choosing the right latitude. So the next time you see a rocket launch from near the equator, remember, the Earth itself is the first stage of every rocket. It's a beautiful trick of physics. If you enjoyed this, follow for more, and try working out the surface speed at your own latitude.